What is up, mathletes? So today we are going to look at solving radical equations, right? We're going to look at all kinds of radicals. We're going to get radical up in here, all right? So we're going to look at solving these radical equations, and I'm going to give you a variety today. So be patient, make sure you take down these notes, and make sure you ask questions in the comments, because again, if you're not careful, this could get confusing. All right, so let's go ahead and let's dive in here. So when we're solving these radical equations, right, you want to do this first. Isolate the radical. Make sure that one radical term is alone on one side of the equation, right? So as you're writing down these steps, and I do recommend you writing down these steps, I'm going to show you exactly what is meant by these directions, all right? Then later, after the video, you put this in your own words. Step number 2, we're going to apply this power rule. I'm going to show you exactly what that looks like. We're basically going to focus, we're going to zoom in on the index, and whatever the index is of that radical, we're going to raise both sides to that index. We'll see what that looks like. Step 3, then we're going to solve. So you might have a linear equation, you might have a quadratic equation, you might even have another radical equation. And so we'll look at what happens when I do have that case. Because in step 3, if you do end up with another radical equation, you just follow steps 1 and 2 again. We'll see. I'll give you a great example here. And then don't forget that you gotta make sure all your solutions work. So you gotta check your work. All right, so enough talk, let's dive in here. Before we dive in here, we put a lot of work into this, right? Me, my team. So please make sure you smash that thumbs up and subscribe, and let's get down to business. Alrighty, so example number 1. So what's nice about this, we're gonna ease our way into this. So step 1 said to make sure that your radical is on one side of the equation, everything else on the other side. That's exactly what we have. You have the radical and then everything else on this side. So this one's very nice to kind of get us warmed up, right? I don't want you to pull a math muscle. So one thing that I have my students do is I have them write the index, even if it's not there, right? So I write the index even if it's not there. And then what I have them also do is copy down the original equation so that they know what the original equation was, so they could see all their steps, right? So we're gonna go ahead, we've isolated this, and now we're gonna go ahead, just like our steps say, and we wanna get rid of the square root. So focusing on the index, right? Here's our index, the 2, so that tells you the power that you're gonna raise each side to. So we have the power that we raise each side to. So we square both sides, and so the radical, the square root and the square, they cancel each other, so you're left with what's on the inside, which is the 2x plus 3, and then we square the right hand side, which gives us 25, and now this looks much easier than it did before, right? Not too bad. So now we have a linear equation, so we just solve this as we normally would. Subtract 3 from both sides, and we're left with 2x, these canceled, equals 22, and now we know we divide both sides by 2. So we get x equals 11. So after each one of these problems, I want you to press pause and actually plug it back in to check, is it correct? Because here, I could simply do this one in our head. So basically I would put this 11 wherever I see x. So 11 times 2 is 22, plus 3 is 25. So the square root of 25, oh, that does give us the 5. So don't forget to check your work. All right, so there's our first example, kind of getting us nice and warm. All right, example number 2. Here we go. Any questions? No, we're good? Okay. Example number 2, very similar, except we have this plus 6 floating around. And remember the first step, it said to isolate this radical. So in isolating this radical, let's go ahead and let's subtract 6 from both sides. Right, we're gonna subtract 6 from both sides and go ahead and do so. So we end up with the square root of x minus 3. And I already hear the YouTube comments coming. Hey, you didn't copy down that equation again. And that equals negative 1. All right, that equals negative 1. So the square root of x minus 3 equals negative 1. Well, let's continue the march. I'm going to give you a great tip in a few minutes, but I'm going to pretend I don't know that tip yet. All right, so let's go ahead, continue the march. I told you we're going to put a 2 there. So let's go ahead and we'll square both sides. All right, so let me copy this down again just so we could see what we're doing. All right, so I'm going to square both sides so I could cancel that square root. Right? And now we end up with x minus 3 equals 1. Right? Negative 1 squared is 1. We go ahead and we solve and we get 3. And a lot of people, they're like, all right, cool, we got a nice answer of 4, we're done. So again, you always want to check your work. So let's plug it in. Let me do my check work over here. So let's plug it in. Plug it in, plug it in. So I got the square root of 4 minus 3. I don't want to make that line too far. And be careful. Check out what I'm going to do right here. I'm going to put a little line here just to indicate that that's where I'm going to stop. Right? That's where the square root stops. All right? And that 4, I'm going to plug it in right there. All right, so I plugged the 4 into our original equation. All right, so 4 minus 3, that gives us a square root of 1 plus 6 equals 5. Well, the square root of 1, that's just 1. So 1 plus 6 equals 5. Well, no way is that true. So right away we say this x equals 4. This is not a solution here. So in this particular example, we have no solution. So make sure you check your work to actually show that it is a solution. All right, here's what I want you to see, because we could have stopped years ago. Just kidding. I want you to focus right here. Here we have the square root of this radical, and we saw that it equals negative 1. Well, when we're talking about these solutions, when we talk about square roots, right, we only want to look at the positive side. So the square root of whatever, we want this to be a positive number. If this is not a positive number, right, because we're looking at the principal square root, meaning only the positive solutions. And so this has to equal a positive number or 0, right, or 0. And so if you ever get a square root equaling a negative, right away you know that it's no solution or your money back. All right, so jot that down. Again, whenever you have the square root or any even index, right, and you get a negative answer over here, that's no solution. Because when you take the square root, we're looking at positive roots. Alrighty, so that will save you some time and money. You'll thank me later, but right now I'm taking payments of likes. Smash that like. All right, here we go. Example number 3. Example number 3. So here we go. Now we're getting a little bit more into beast mode, right? We're going beast mode up in here. So what I want to do is I want to isolate the radical. That square root, we want it by itself. So I need to, all right, let me go ahead and copy. I can hear the comments already. Let me copy this down. So I copied down my original equation. And now I'm going to isolate the radical. Isolate the radical. So I'm going to subtract x from both sides. All right, so when we subtract x, what we're left with on our left-hand side is the square root of 26 minus 11x. And on our right-hand side, we're left with 4 minus x. Here's where all the additional work comes in this problem, all right? The additional work comes because I know now that I have to square both sides because my index is 2. Remember, if your index was 3, then this would be a 3, right? You would cube both sides. All right? So jot that down, very important note. And so we're gonna square both sides. All right, so we know the radicals cancel on the left-hand side. So you're left with 26 minus 11x. And on the right-hand side, notice you're squaring it. So you have two copies. So we're left with 4 minus x and 4 minus x. All right, so let's go ahead and let's distribute everything. And before we continue, let's get a word in from our sponsors. Oh, that's right, we don't got any sponsors. All right, so let's go ahead and continue. So we're gonna distribute, we're gonna FOIL this. So we get 16 minus 4x, gonna distribute that negative x to both of those terms, minus 4x plus x squared. On our left-hand side, nothing happened. So you're left with 26 minus 11x. What I want you to write down here is what type of equation do we have? And right here, notice we have a quadratic equation. It's quadratic because our biggest exponent is 2, right? And whenever we have a quadratic, we need to set one side equal to, bam, 0. So write that down. Whenever you see a quadratic, we set one side equal to 0. So let's go ahead and clean things up here and let's take a look. So let me combine like terms before we do so. So we're left with 26 minus 11x equals 16 minus 8x plus x squared. All right, so now we're gonna set one side equal to 0. So I'm gonna subtract 26 from both sides, and then I'm gonna add 11x to both sides because I wanna set one side equal to 0. So minus 26 and plus 11x. All right, so one side, now I have it equal to 0. So I get negative 10 there. I get positive 3x there. And I get plus x squared there. So because it's quadratic, I have a few options. Hopefully this is gonna be factorable. I hope that I'm gonna be able to factor this, all right? If not, I'm gonna have to use the quadratic formula. Yes, there's other ways, but those are the two easiest, right? So let's see if we could factor this. So what we're gonna do is let me rewrite this in descending order. So let me copy this and let's rewrite this. Copy this bad boy. And let's rewrite this in descending order. So what we have is we have 0 equals x squared plus 3x minus 10. So we have to factor this trinomial. If you need help factoring trinomials, we got a video down in the description for you. All right, so we got 0 equals x plus 5 and x minus 2. The reason being, 5 times negative 2, that multiplies to give me negative 10. But at the same time, tell him, Johnny, 5 times negative 2 equals 3, right? So again, if you need a review on the factoring video, boom, go ahead and click that button down below and we'll hook you up. So now we have x plus 5 times x minus 2 equals 0. So what we do using our zero product rule is we set each one of those mother factors equal to 0. All right, so we set each one equal to 0. And now we solve. So let's go ahead and add 2 to both sides, add 2 to both sides. And this one we're gonna subtract 5 to both sides. And so you get x equals negative 5 for one of our possible solutions, because make sure that you check your work. And over here, we got x equals positive 2. So now we need to check our work, and we're going to go ahead and plug these in. And remember, where do you plug them in? You plug them back into the original equation. All right, so here we have our original equation and we have our two possible solutions. All right, so what we're going to do is we're going to plug each one of those in one at a time. So I'll do one and then I want you to do the other. All right, so I'm going to go ahead and plug in the -5 and then you plug in the 2. So I got -5 plus the square root of 26 minus 11 times -5 equals 4. All right, so let's go ahead and evaluate this. Let's go ahead and simplify everything. So we end up with 26 plus 55. And notice I wrote that little, this guy right here so that I know where the radical stops. It stops right after the 55. Right? You don't have to do that, but for me it's helpful. For a lot of people it's helpful. So we're left with -5 plus the square root. Let's go ahead and add those two and we get the square root of 81, which is nice because that's a perfect square, equals 4. Square root of 89, well, that's just going to give us 9. Sorry, square root of 81, jumping ahead of myself. And that equals 4. -5 plus 9, that is 4. So we have 4 equals 4. So what we see is that -5 is a solution. It works. And so again, what you're gonna do is you're gonna take that that +2, and you're gonna plug it in and you're gonna see if it works. And I'll just tell you that it does, but I still want you to go through the process, right? You verify that. And so since they both work, we have two solutions. We have -5 and 2. So those are our two solutions here. All right, so this is what the process looks like when we're solving radical equations, right? And again, the more you practice this, the more you get comfortable with it and you get things start to happen, right? You get very familiar with this. So again, don't stress out, just be patient with yourselves. And again, if you have questions, Dr. Math is here for you. So don't forget to comment down below, like, share this video, help the channel grow, and we'll see you next time. Peace.